Hello, and welcome back to the Humanoid Leaders series. I'm thrilled to be joined by Cade Johnson, a mechanical engineer at Liquid Wire. Today, we're going to be discussing the use of stretchable electronics within humanoid robots. Thanks very much for joining me, Cade.
Yeah, of course. It's great to be here, Jack.
Could you begin by giving an introduction to Liquid Wire and discussing some of your core technology?
Liquid wire is the next generation in the printed circuit industry. So to put it simply, you started with PCBs that were rigid boards, and then FPCs were the next thing that was developed, which had a bit more movement. They were flexible, but now we've added an additional dimension to that. So structures that are completely deformable and stretchable, like you can see with this wire here. This is enabled by metal gel, which is our core technology. It's a conductor that stays in its liquid state for the entirety of its life. It allows it to do everything that a flex circuit can't do. You might expect with the flex circuit that has copper as its conductor to fatigue over time. It can work hard, and even though it's a little bit malleable, metal gel just offers a bit more robustness because it stays in its fluid form and can move with the channels of the deformable substrates.
Thank you very much. And where are deformable electronics typically used within humanoid robots?
There's three main use cases that we traditionally see. So it can replace an FPC anywhere that it might be going over a joint angle, or just anywhere on the robot in general. There are often some integration and manufacturability advantages that you can have with our technology. But if you're seeing an FPC break, it's often a good solution to use our technology to put it in there because we can survive those multi-axis movements that the robots are demanding. Also with proprioception, so we can pick up on joint angles using our strain sensing technology, correlating the strain to joint angles and the resistance change that you might see. Often we are less environmentally sensitive than you might see with the Hall effect sensor, or easier to integrate and have a better form factor than a rotary encoder. We also offer tactile sensing solutions, so you can know where the robot's being touched and how hard it's being touched.
And what are some of the main features a humanoid manufacturer needs to consider when integrating deformable and stretchable circuitry?
So one of the main things is that we are able to manufacture to most of the needs that your schematic might offer. So we can pattern our conductors. We have a lot of freedom around how we pattern our conductors. So we can interface with interposers that can connect to any receptacle that you might already have on the robot. We can also host sensors and microcontrollers or other kinds of printed circuits directly, as you can see with this design where we have a microcontroller here hosted directly on the deformable electronic, and then an IMU sensor out here. So there's many different ways that you can pattern and integrate our technology into your robot.
And what characteristics should manufacturers look for when selecting interconnects or sensors?
Yeah, the main thing is durability, durability, durability. You don't want to lose electrical performance over the millions of multi-axis cycles that these robots are demanding. That's really it.
Thank you very much. And what products do Liquid Wire offer to the market?
The stretchable interconnects are, again, one of the big ones. You can communicate over most communication protocols, CAN, I2C, SPI, and send power over our wires, as well as use our technology as a strain sensor. So we offer our strain sensing solutions and then the tactily sensitive overlays. So those last two that do the sensing can be customized to maximize signal anywhere that you want on your robot. We can adjust resolution of the tactily sensitive arrays to get finer resolution on places like the hands, or more coarse resolution on parts of the arm or the body, just to optimize for signal processing while still getting the desired information that you need in those locations.
Perfect. And so now could you go into a bit more detail about Liquid Wire's interconnects and how they differentiate from their competitors?
So as stated before, our interconnects are deformable. As you fold and roll and twist them, we can continue to act as a conductor in ways that other technologies can't, simply because our metal gel never cures and it stays in its liquid form. One of the most important things that we offer is smaller form factor in really space-constrained environments. So often to overcome these limitations of FPCs, robot manufacturers have to introduce service loops or other solutions in order to add space for their FPCs or their cables. And with ours, when you expect it to just stretch, you can reduce that form factor because you don't have to have all the space that you would previously have to have.
Thank you. And how do your stretchable strain sensors give humanoid robots proprioception and control?
So we actually started as a medical wearable company a few years back where we were working to pick up the joint angles of people in physical therapy to monitor their recovery, or in industrial environments to look for workplace injuries. And doing clinical studies, one specifically that came out in 2023, found that we are just as accurate as a professional might be with the tools that they're using. And that directly correlates over to the humanoid robot, because in the same way you're picking up joint angles and you can feed that data back to the robot so it can know exactly where its joint angles are and how they might be infected by the environment, or just helping with control systems to give the feedback they need to, figure out exactly where their limbs are. We've also produced a data glove as well that can pick up 3 degrees of freedom on the human hand or even a robot hand.
Perfect. And if I'm a humanoid manufacturing engineer, where can I learn more about Liquid Wire?
You can find us on our website or on LinkedIn. We also have eval kits that you can purchase that just get you a hands-on experience so you can feel the tech and really get a feel for how you might integrate it and how it works. We'll also be at IEEE ICRA in Atlanta in May.
That's brilliant, Cade. And where do you envision humanoid robotics is heading, and how does Liquid Wire envision its involvement?
So as industry leaders will tell you, to take advantage of the large behavior models, you need to have good data. You can develop the software all you want, but if the data coming in isn't accurate, then your models won't be accurate, and you might be missing a lot of crucial information. And these two things, the software and the hardware side of things, where you're actually picking up the data, need to develop together. And to that end, we're working with the hand ERC at Northwestern because we're focused on that vision, and so are they, so we can develop solutions to pick up unique data that has a lot of value to these behavior models and robot manufacturers.
Cade, it's been a pleasure speaking with you, and thank you very much for your time.
You bet. Thank you.